Hi students and friends, this is your host and teacher Sayyid Ayazuddin Haider and you are watching Learn and Teach by Sir Ayaz. So I will continue my video session for the past papers and this time I have selected 0620 variant 41 and it is May-June 2023. You know this is paper 4 theory extended version. The timing for this paper is 1 hour 15 minutes. You must answer on the question paper. No additional materials are needed. The total marks for this paper is 80. Periodic table is printed in the question paper. So let's start the paper. This is question number 1. Some symbol equations and word equations A to J are shown. So from A, B, C, D, E, F, G, H, I, J. You can see there are different symbol and word equations. Use the equations to answer the questions that follow. Each equation may be used once, more than once, or not at all. A. Give the letter A to J for the equation that represents a neutralization reaction. Remember, a neutralization reaction involves the reaction between H positive ion and OH negative ion, and we will get H2O. So here we have B in your answer. So B will be the answer for this part. B, a precipitation reaction. What is a precipitation reaction? Precipitation reaction involves the formation of insoluble solid. So if you look at all the reaction equations, in equation A, I can see this FeOH whole thrice, which is iron 3 hydroxide. It is insoluble in water, which means it will form precipitate, meaning it exists as solid. The other equations, B is neutralization reaction, C is organic reaction, D is also organic reaction, E organic reaction, F displacement reaction between chlorine and aqueous potassium iodide, G this is the fermentation reaction, H organic reaction, I decomposition reaction, J this is a reaction for photosynthesis. So automatically A will be the right answer for a precipitation reaction. C, the formation of an ester. If you look at these choices, you can easily see that the reaction between ethanoic acid and ethanol results in the formation of ester, which is ethyl ethanoate. This is ester plus water. So H must be the right answer for number C. D, photosynthesis. It's very easy. Photosynthesis reaction involves carbon dioxide and water. The products will be glucose and oxygen. So G will be the answer in this case. Next one, fermentation. Fermentation reaction involves the conversion of sugar into ethanol and carbon dioxide. And if you look all the choices here, we have only one reaction which shows this reaction, which is G here. This is glucose and the product is ethanol and carbon dioxide. So G will be the right answer for E. Last one, cracking. Cracking involves breakdown of long chain alkanes. In order to get, we have two possibilities. smaller alkane plus alkene or alkene plus hydrogen gas. So let's see the choices. If you look at all the choices, you will find this reaction as cracking. Number D. This is etherdecane, etherdecane, and it's broken down to produce octane. This is octane, and butene. This is butene. This is octane, and this one is butene. So alkane and alkene. So this must be the answer for this choice for number F. So write D here. Number 2, A. The symbols of the elements in period 2 of the periodic table are shown. We have Li, Be, B, C, N, O, F, and E. Let me show you these elements in the periodic table. This is the periodic table. You see these are in the second period. This is second period. Li, Be, B, C, N, O, F, N, E. So these are from second period. Use the symbols of the elements in period 2 to answer the questions that follow. Each symbol may be used once, more than once, or not at all. Give the symbol of the element that, number 1, makes up approximately 78% of clean dry air. This is very easy. You know that nitrogen is a gas which makes up 78% of clean and dry air. So N will be the answer for this question. Number 2, contains atoms with only 3 electrons in the outer shell. Coming back to this periodic table, you can clearly see that in the second period you have boron, which is an element which contains 3 electrons in its valence shell because it is in group 3. Group 3 means it must have 3 valence electrons. So you can write B here. Number 3, contains atoms with only 9 protons. Simply you have to look at the proton number. So if you look at this periodic table, you will find fluorine as having 9 as its proton number, which means it must have 9 protons. So F is the answer for number 3. Number 4, exists as graphite. Graphite is the allotropic form of carbon. So straight away you will write the symbol C here. Number 5 is an alkali metal. You see, first element, that is Li, belongs to group 1. These are alkali metals. Group 1, alkali metals. So you will write the symbol Li here. Number 6, only has an oxidation number of 0. This element must belongs to group 8. Here we are having group 8. They have 0 as their oxidation number. So neon will be the answer for this part. So I will write Ne. B, boron B has 2 isotopes. 1, state the meaning of the term isotopes. They are asking the definition of the isotopes. You know, they have different atoms of the same element with the same number of protons or proton number and different number of neutrons or nucleon number. So I will write different atoms of the same element with the same number of protons or proton number but different number of neutrons or nucleon number. Number 2, table 2.1 shows the relative masses and the percentage abundances of the two isotopes of boron. Here we have relative mass of isotope 10, 11. Percentage abundance for 10 is 20, for 11 is 80. Calculate the relative atomic mass of boron to one decimal place. What you have to do, you have to multiply the relative mass by the percentage and add up these values. So 10 multiplied by 20 bracket plus 11 multiplied by 80 bracket close divided by 100. Let's do the calculation. So 10 multiplied by 20 gives 200 plus 11 multiplied by 80 gives 880. So finally 200 plus 880 divided by 100 gives 10.8. 10.8 will be the relative atomic mass for this boron. Question number 3. This question is about ionic and covalent compounds. A1. Sodium reacts with oxygen to form the ionic compound sodium oxide. The electronic configurations of an atom of sodium and an atom of oxygen are shown in figure 3.1. This is figure 3.1. We have sodium atom, we have oxygen atom. Ions are formed by the transfer of electrons from sodium atoms to oxygen atoms. Complete the dot and cross diagrams in figure 3.2 to show the electronic configuration of one sodium ion and one oxide ion. Show the charges on the ions. So first of all, you should know how many atoms of each of these elements involved in the formation of ionic bond. So we have sodium and oxygen. This is a symbol for sodium, symbol for oxygen. Sodium belongs to group 1. Here we have sodium. Valency for group 1 is +1. What about oxygen? Oxygen belongs to group 6. Valency is -2. So I will write +1, -2 here. Ignore the charges. 1, 2. These subscripts will be exchanged. 2, 1. So we'll get Na2O. This will be the formula for the compound formed between sodium and oxygen, which means that each of the sodium atom will be donating their valence electrons, and it means one oxygen atom will receive 2 electrons at a time. So let's show the valence electrons of sodium. Each sodium, after losing their valence electron, will be left with 10 valence electrons. Look at the proton number. 11 is a proton number, which means it has 11 electrons. Initially, sodium have 11 electrons. After losing this electron, it will be left with 10 electrons. So it's a positive ion. After losing one electron, it will acquire positive charge. So I need to show 8 more electrons. 2 electrons are already shown here. So 1, 2, 3, 4, 5, 6, 7, 8. So here we have all the electrons of sodium, and I will place plus charge here. What about oxygen? Oxygen. Here is oxygen. Proton number of oxygen is 8, which means it has 8 electrons. 8 electrons. So it has received 1 electron from the from each of the 2 sodium atoms. So now it has 10 electrons, which means it will acquire -2 or 2 minus charge. So in the valence shell, I have to show 2 electrons from the sodium atom. So here we have electron from sodium 1 and 2. Now let's show the valence electrons of oxygen. Look at the group number again, group 6. It must be 6. 6 valence electron for oxygen. 1, 2, 3, 4, 5, 6. So I will write 2 minus here. It has gained 2 electrons, and therefore it will acquire 2 minus charge. Number 2, write the formula of sodium oxide. I have just worked out the formula. I will do this again. Sodium, oxygen. Sodium belongs to group 1, +1. Oxygen belongs to group 6, -2. Ignore the charges, 1, 2. Subscript will be exchanged, so we will get Na2O. This will be the final formula for sodium oxide. B. Carbon dioxide, CO2, is a covalent compound. Complete the dot and cross diagram in figure 3.3 to show the electronic configuration in a molecule of carbon dioxide. Show outer shell electrons only. So CO2, meaning we have only one carbon atom. Look at the position of carbon here. Here we have carbon. This is carbon group 4, which means it has 4 valence electrons. Now I'm showing the key here on the right hand side. For carbon, I am using cross. For oxygen, I am using dot. So first of all, I will show the 4 valence electrons of carbon. 1, 2, 3, 4. What about oxygen? Oxygen belongs to group 6. Here it is. Here it is oxygen. 6 valence electron. Each oxygen atom having 6 valence electron, they will be sharing 2 of their valence electrons with carbon atoms. Reason, they need 2 electrons to complete their valence shell. So 2 electrons of oxygen for the right hand side, 1, 2, 3, 4, 5, 6. Left hand side, 1, 2, 3, 4, 5, 6. So this will be the final dot and cross diagram for carbon dioxide. C. The melting points of sodium oxide and carbon dioxide are shown in table 3.1. Table 3.1. This is the melting point of sodium oxide, 1275. Carbon dioxide, -78. Number 1, explain in terms of bonding why sodium oxide has a high melting point. It must be related to the strong electrostatic attraction or strong bond. Strong bond or strong electrostatic attraction. So it must be between the oppositely charged ions, between positive and negative ions. Number 2, carbon dioxide has a low melting point. State the general term for the weak forces that cause carbon dioxide to have a low melting point. It must be intermolecular forces. So write intermolecular forces. Next question. Oxygen is produced by the decomposition of aqueous hydrogen peroxide, manganese 4 oxide. MnO2 is a catalyst for this reaction. A, state the meaning of the term a catalyst. Catalyst increases the rate of reaction. As it's of 2 marks, so you have to tell something about the catalyst, that is remain unchanged at the end of the reaction. So you write increases the rate of reaction. Increases the rate of reaction. Next statement will be remain unchanged. Remain unchanged at the end of the reaction. At the end of reaction. Part B. A student adds powdered manganese 4 oxide to aqueous hydrogen peroxide in a conical flask as shown in figure 4.1. The mass of the conical flask and its contents is measured at regular time intervals. The mass decreases as time increases. This is aqueous hydrogen peroxide here, and we have powdered manganese 4 oxide. We have loosely fitting cotton wool plug. This is the balance. 1. State why the mass of the conical flask and its contents decreases as time increases. If you look at the reaction, what is happening? You have oxygen produced during the decomposition of H2O2. So you have H2O2, when H2O2 decomposes, it produces oxygen gas. It's a gas. So oxygen escapes from the apparatus. Oxygen escapes from the apparatus, or you can name the apparatus, that is conical flask. Number two, the rate of reaction is highest at the start of the reaction. The rate decreases and eventually becomes zero. Explain why the rate of reaction is highest at the start of the reaction. So at the start of the reaction, you have a higher concentration of H2O2. So there will be higher collision frequency in the beginning. This must be the reason. So you write concentration of hydrogen peroxide of hydrogen peroxide is highest at the start of reaction or you can even write there will be higher collision frequency or there will be higher collision frequency at the start of the reaction. Number three, explain why the rate of reaction eventually becomes zero. Definitely, hydrogen peroxide is used up or reacted or decomposed. Hydrogen peroxide is decomposed or reacted or used up. You can write any one of these. C, the experiment is repeated at an increased temperature. All other conditions stay the same. Explain in terms of collision theory why the rate of reaction is higher at an increased temperature. On this is of 3 marks. First of all, you will talk about the kinetic energy. That is, kinetic energy of the particle increases, then there is increase in the frequency of collision. Then you have more particles or higher number of particles having energy greater than or equal to activation energy. Kinetic energy of particles increases, and you can say increases the frequency of collision. Increases the frequency of collisions between particles. Higher number of particles have energy greater than or equal to activation energy. D, the equation for the decomposition of aqueous hydrogen peroxide H2O2 aqueous is shown. This is a reaction. 2H2O aqueous gives 2H2O liquid plus O2 gas. 50 centimeter cube of a 0.2 mole per dm cube solution of H2O2 aqueous is used. Calculate the mass of O2 that forms. Use the following steps. Number one, calculate the number of moles of H2O2 used. So you have the volume of H2O2 and the concentration of H2O2. So we have a concentration 0.2 mole per dm cube, which means that it is 0.2 mole in 1000 centimeter cube. This is the relationship between dm cube and centimeter cube. So you'll write 1000 centimeter cube contains 0.2 moles. Therefore, 50 centimeter cube contains X moles. To the cross, we will get what? We will get 1000X is equal to 0.2 multiplied by 50, or X is equal to 0.2 multiplied by 50 divided by 1000. What we will get? 0.2 multiplied by 50 divided by 1000. 0.01 moles. Determine the number of moles of O2 produced. So how we will calculate the moles of O2 produced? Look at the equation. 2 mole of H2O2 produces 1 mole of O2. H2O2, 2 moles. Therefore, 0.01 moles produces X mole of O2. Do the cross. What we will get? We will get 2x is equal to 1 multiplied by 0.01, or x is equal to 0.01 divided by 2. 0.01 divided by 2, 0.005 moles of oxygen. Now you have the moles of oxygen, you can easily calculate the mass of O2. Look at the position of O here. Here's the periodic table, here is O, AR is 16, and we have 2 here. So MR of O2 is 2 multiplied by 16, 32. So you simply multiply 32 by 0.005. The formula is AR or MR into mass into number of moles. So what we will get? 32 multiplied by 0.005, 0.16 gram. This will be the final answer. E. State the effect on the mass of oxygen produced if the mass of powdered manganese 4 oxide catalyst is increased. It is acting as catalyst, so there will be no effect. Catalysts have no effect on the mass. It just speeds up the reaction. F. Oxygen can also be produced by the decomposition of mercury 2 oxide, HgO. The only products of this decomposition are mercury and oxygen. Write a symbol equation for this decomposition reaction. So it's of 2 marks, which means that we have to balance the equation. What is the formula of mercury 2 oxides given? HgO. Formula for mercury is Hg, and we know that oxygen exists in the molecular state, so we will write O2 here. Let's balance the equation. I need to write 2 here before 2HgO in order to balance the oxygen on the product side. So now for Hg on the product side, we need to put 2. Now the whole equation is balanced. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.